Bismillahirrahmanirrahim. Dear students, this is Inorganic Materials Chemistry, Chem 3115, and in this lecture I will talk about Introduction to Nanomaterials. The key concepts of this lecture includes nanomaterials introduction, their classification based on dimensionality, morphology, and composition. In this lecture, I will talk about introduction to nanoscale materials, which are also called nanoparticles or nanomaterials. Moreover, I will talk about their classification, which will help us to understand the basic concept of nanomaterials. The question is, nanomaterials, what is the concept of nanomaterials? According to Nobel laureate Richard Feynman, who gave a visionary lecture, and in his visionary lecture he says that there is plenty of room at the bottom. What does it mean? He gave the concept of nanotechnology at that time when the researchers were not working on nanomaterials. According to Richard Feynman, he says that what I want to talk about is the problem of manipulating and controlling things on a small scale. What does it mean that manipulating and controlling things on small scale? According to Richard Feynman, the materials can be grown into smaller and smaller size until we reach atomic or molecular level. So this is the plenty of room at the bottom. It means if we move from microscopic size to small size, we can move to atomic or molecular level, which is far smaller than nanomaterials. The term nano is derived from Greek word nanos, which is used for dwarf. Dwarf means in daily life we can use this word for those people who are shorter in their length. This etymology and its placement on the metric scale, 1 nanometer is equal to 10 raised to power minus 9 meter, shows that tiny dimensions not visible to naked eye beyond the normal limits of our observation. It is well known that the diameter of hair is 100 micrometer. If we compare the diameter of hair, which is 100 micrometer, to the Buckminster fullerene, which is 1 nanometer in size, and it has been shown on next slide in figure 1.1. Nanomaterials are defined as materials having at least one dimension in the 10 to 100 nanometer range, in which nanoparticles are the major investigated subjects. The term nanoparticles was first appeared in 1980s. This is figure 1.1. This figure explains some materials and some particles. This is the length scale for classifying nanomaterials. On the right hand side of the figure, we can see diameter of a hair. It is 100 micrometer. From here to red blood cells, we can see there is a decrease in size. The red blood cells are in the range of 10 micrometer size. E. coli is 1 micrometer in size, and we can see HIV viruses, they are only 100 nanometer. A molecule of hemoglobin is 10 nanometer in size, and Buckminster fullerene, which is a carbon compound, 60 carbon atoms are interconnected to forming a cage structure. Its size is 1 nanometer, which I have mentioned on previous slide. If we compare the diameter of hair to Buckminster fullerene, which is made of 60 carbon atoms, and its size is 1 nanometer. We can also find nanoparticles or nanomaterials in the history. In this slide on the right hand side, this figure, it is actually ancient stained glass. Many people in the history, they have been using different metals like gold, silver and other previous to stain different architectures. At that time, people did not know that what they were using, the gold materials or silver materials, their solutions, their colloidals, they were actually in nano size. Later on, when characterization techniques have been developed like scanning electron microscopy, transmission electron microscopy, and when these pictures were analyzed on high resolution, it was found that the pictures are made of small dots, just like yellow dot, blue dot. These dots are made of very tiny particles of gold, silver, and other precious metals. Here is a question: nanoparticle or nanomaterial? Sometimes when we read the literature, we can see both of the terms nanoparticle or nanomaterials. Here are some definitions by standards to define these terms given in the table. These are the organizations just like ISO International Standard Organization, ASTM, NIOSH, SCCP, and some others. These are the definitions according to these organizations. We can see for a nanoparticle, according to ISO, a particle spanning 1 to 100 nanometer diameter, an ultraphy particle whose length in 2 or 3 places in 1 to 100 nanometer. This is some other language other than English. A particle with diameter between 1 and 100 nanometer, at least one side is in the nanoscale range, and on the other hand, material for which at least one size or internal structure is in the nanoscale, or material for which at least one size or internal structure is in the nanoscale. Material consisting of a nanostructure or a nanosubstance. So all those particles or materials which are 1 to 100 nanometer or their one or more than one dimensions are in the range of 100 nanometer, they are called nanoparticles or nanomaterials. The nanoparticles are so small that if we take a cross section of a hair, 50,000 nanoparticles can accommodate on the cross section of the hair. I can also ask you a question: have you ever seen nanoparticles in your daily life? We are talking about nanomaterials whose diameter is 1 to 100 nanometer, and this diameter is even smaller than the wavelength of the visible light, which is from 400 to 700, and in some books from 350 to 750 nanometer. So when we compare the diameter of the nanoparticles, which is very small, it means that we cannot see these materials using our naked eye under visible light. However, the nanoparticles are always dispersed in the air in large quantity. If we see some sunlight which is coming from a window, you can see some particles are illuminating, or if you stand in front of a multimedia, you can see some particles are blowing in the air. So these are the nanoparticles. Nanoparticles can be classified into different classes depending upon their dimensionality, morphology, and composition. So first of all, we will talk about dimensionality. Nanoparticles can be divided into three categories: one-dimensional nanomaterials, two-dimensional nanomaterials, and three-dimensional nanomaterials. 1D materials are those nanomaterials which are in nanoscale with one dimension, typically thin films or surface coatings. Thin films have been developed and used for decades in various fields, including electronics, information storage systems, chemical and biological sensors, fiber optic systems, and magneto-optic and optical devices. Thin films can be deposited by various methods and can be grown and controlled at atomic level, a monolayer where one layer of the atoms can be deposited on the surface of the material. 2D nanomaterials or two-dimensional nanomaterials have two dimensions in the nanometer scale. Two dimensions means they are in nanoscale size on x or y axis or on x or z axis. 3D nanomaterials are three-dimensional nanomaterials that are nanoscale in all three dimensions. These include quantum dots or nanocrystals, fullerenes, particles, pesticides, and colloids. Some three-dimensional systems such as natural nanomaterials and combustion products, metallic oxides, carbon black, titanium oxide, zinc oxide, they are also well known, and others such as fullerenes, dendrimers, quantum dots represent the greatest challenge in the term of production and understanding of properties. While talking about dimensionality, one-dimensional, two-dimensional, and three-dimensional materials, Another type of nanomaterials is zero-dimensional materials, which is often not discussed in classification. Here is a picture which is representing zero-dimensional, one-dimensional, two-dimensional materials and some complex structures. Zero-dimensional materials are just like dots, spheres, cubes. On the other hand, one-dimensional materials, they are in nanoscale. Along one dimension, they are usually rods or wires. They are usually rods or wires we can see in this figure. Two-dimensional materials, their size is in nanoscale along two dimensions. These are just like disks. Two-dimensional nanomaterials are those nanomaterials which are in nanoscale size along two dimensions, just like x-axis or along y-axis. These are also usually just like disks or rods. There are also some complex nanostructures which are either three-dimensional nanostructures or condensed three-dimensional structures. These are helix, some stars, some tetrahedral structures. So all of these structures, these are three-dimensional nanomaterials. Figure 1.3 represents some examples of metal-containing nanoparticles whose shapes are given here. First of all, zero-dimensional nanomaterials, they can be spheres, spheroids, hollow spheres, nanocrystallites, or hollow nanobox shaped materials. One-dimensional metallic materials can be nanorods, nanofibers, nanowires, or hollow nanotubes. Hollow nanotubes means these are empty from the inside. Two-dimensional nanomaterials, which are metal containing nanoparticles, they can be nanodiscs or nanorolls. Nanomaterials can be classified on the basis of their morphology. The morphological characteristics to be taken into account are the flatness, aspect ratio, and spatial position of each element in the case of hybrid nanoparticles. A general classification exists between high and low aspect ratio particles. High aspect ratio nanoparticles include nanotubes, nanowires. On the other hand, small aspect ratio nanoparticles include spherical shaped, oval shaped, cubic shaped, prismatic, helical, and pillar shaped nanoparticles. Transmission electron microscopy can be used to see the exact morphology of the nanoparticles. As an example, the TEM images of some nanomaterials with different morphologies are given on the next page. These are different morphologies of the nanoparticles which have been studied by using transmission electron microscopy. In this figure 1.4, the A figure, it is monodispersed copper nanoparticles. These particles are very small in size. Figure B represents iron nanoroids, and similarly in figure C it can be seen copper silicon core shell nanoparticles. Core shell nanoparticles will be described later. Similarly in figure D, porous iron oxide nanoparticles. Figure E is representing iron oxide cubes decorated with nickel nanoparticles. Figure F is representing porous silica spheres with alpha iron oxide nanoparticles which are embedded in pores of silicon oxide. Similarly, in figure G, gamma iron oxide nanoparticle spheres are shown. The third category of nanoparticles is the composition of the nanomaterials or nanoparticles. Nanoparticles can be divided into three types: mixed nanoparticles, core shell nanoparticles, or layered nanoparticles. Mixed nanoparticles can be either random or ordered. figure 1.6, which is on the next page. It is showing mixed nanoparticles. Randomly mixed alloys correspond to solutions of solids, whereas ordered nanoparticles correspond to ordered arrangement of A and B atoms. The A and B atoms are shown in figure 1.6. Core shell nanoparticles consist of a shell of one type of atom B surrounding a core of another type of atoms A. It is also represented on the next page. Layered nanoparticles are commonly referred to in the literature as genuous nanoparticles. They consist of two types of nanoparticles, A and B, sharing a common interface. This is shown in figure 1.6c. These type of nanoparticles tend to minimize the number of bonds between elements A and B. This heterojunction structure facilitates phase separation. Here is the figure 1.6. The A shows mixed structure nanoparticles. We can see A and B atoms are mixed in the cluster structure. The atoms are randomly arranged among the structure of the nanoparticles. The figure B is representing core shell structure. In this structure, the B atoms are making a core shell and the A atoms are embedded in the core shell structure. This is second type of nanoparticles. The third one, figure C, is representing layered structure. In this structure, we can see the A atoms, they are making one kind of layer, and B atoms, they are making second kind of layer. These atoms are continuous in A layer. Similarly, the atoms in B layer, they are also continuous. This is layered structure. The references for this lecture are There is Plenty of Room at the Bottom by Richard Feynman. It is book published in 1999. The second one is Introduction to Nanoparticles by Satoshi Horikoshi and Nick Sarpon. So these two books can be downloaded from the internet. The assignments are students have to find more examples showing different type of nanoparticles depending upon their morphology and size. Students have to search the detailed history of nanoparticles and make a comprehensive report. The students should search different metal oxide nanoparticles examples and show their physical properties. Thank you very much.